All right, good morning, everyone. Looks like we got two people here so far. Just let me know who's here so I have an idea. It looks like three. Just let me know how you guys are doing. Give me some feedback. All right. Is everything okay? Can you guys hear me? Rachel said yeah. Thank you, Rachel. Looks like maybe one more person's here. All right, so today, just like the Google Classroom says, we're going to be doing Unit 6 Progress Check Part 1, so multiple choice Part A. That should be posted, so go in and check, make sure. I did assign it to you guys. And then there's also the Khan Academy assignment for homework, but we might be able to get it done in the next hour. So the plan is just you guys can work on it however you please. I'll be here, and then any questions you have, I'll go over. I can go through step by step or just clear up some general questions. So, yeah, just let me know if you guys have any questions on that. I don't know everyone who's going to be in the stream. It looks like it says I have 2 viewers, but I don't know if that's accurate or not. But so yeah, get started. Let me know if you need anything. Morning, Mr. Colan. How are you doing today? Oh, you did spell morning wrong. I don't know if that's a good sign by your math teacher, not an English teacher. Not bad, good. Slow fingers. Are you starting your lessons today? Today the first day? In about 15, have loading pre-record live already this one. Nice. Looks like we're figuring this thing out. Let me know if you need anything. I'm still working on stuff too, but yeah, this is my BC class. So I'm all for all I know. I think Rachel's the only one watching right now. So she's doing some work, and then if she has any questions, she can ask me. But I don't know if there's anyone else in here. So this is how our BC class works. Okay, Liberty's here. All right, so we got two people at least. If I had to guess, Cole's probably not here. Typical. All right, we'll do, Mr. Cohen. So Liberty, I don't know when you got in, but we're just working on College Board. So multiple choice question part A of Unit 6. So I have that assigned, so you can work on that just like always, like I said. Any questions you guys have as you go, or if you want to check your work as you go, just type in the chat so I know and I can go over some stuff or just give you answers. You guys could, in the chat, just comment where you're at right now, just so I have an idea of what pace we're at. Three? Okay. Thank you, Liberty. Just finished three? Okay. Perfect.
Well, if you're viewing, let me know you're there so I can answer the questions that you might have so I know who I'm talking to. So how are you today? Luke, you can hear me. Awesome. Is it a big delay? I'm going to take that as a yes since I haven't got a response from you yet. Well, Luke, just move on to number 6 then, Mr. Harris. Sorry. Trying to keep my sanity in this place.
Did not think the day would come when Mr. Colahan was streaming on YouTube, but it's officially here. It's a sight to see. If you guys get a chance, just out of curiosity, I'm curious how you're approaching the Riemann sum problems. So I know a lot of people, their first instinct is to make rectangles, especially if it specifies left rectangles, right rectangles. But you can also use summation notation. So just let me know if that's something you would be interested in hearing. It's just going to involve. It's not you're not saving a ton of work, but it is going to. You don't have to draw a picture or anything like that. It's a little bit easier to follow the process in some cases. So just let me know what you think. I've been using summation notation. Okay, cool. I don't know. I personally think summation notation is easier, especially if you remember how you can set it up. Maybe not even easier. Maybe it's just a little bit less thinking. Honestly, as long as you can get the height for each one and the width of each interval. I don't know. To me, it seems a little bit easier. But a lot of times, from what I've noticed, AP has a tendency to like say exactly what they want you to do, meaning that they'll give you a problem where it'll be, solve this or approximate the area underneath this curve using a right Riemann sum, or it'll say using a sum of rectangles, like 4 equal length rectangles. So it'll specify a lot of times. So I just want to make sure we're comfortable with both. Usually, though, summation notation seems to be what gives people more of the problem. So just wanted to double check, see kind of where you guys were at with that. Hopefully this isn't too much of a delay. I don't know if you guys are listening to me the whole time, or if you mute me and do your own thing, or I don't know what, but Rachel, hey, can you explain how the heck we do problem like number 5? All right, no problem, Rachel. So let me pull this up. Go here. All right. So which of the following limits is equal to 2 to 5? The interval 2 to 5 is the square root of 1 plus x to the fourth. Okay, so basically what we're looking for, so this is number 5. We want to find the Riemann sum from 2 to 5. So you guys, it's been a while, I know, but during Calc AB, you learned about the definition of a Riemann sum, which is basically what this problem is saying. So an integral is equal to the limit as n approaches infinity of the infinite summation of whatever your Riemann summation notation is. So what we're doing is we really want to just find this Riemann sum from 2 to 5. Okay, in order to do that, first of all, we need the width. And then to find the width, what you want to do is you want to take your two endpoints, which is 5 and 2. So you want to subtract those and divide it by how many times you're breaking it up. When I say breaking it up, I mean how many times n, or how many rectangles or shapes you're making. So we represent that by n because we don't know. And it's going to change our answer depending on what n is. But for right now, we just have the variable n, in which we know that 5 minus 2 is 3. And 3 divided by n is going to be your width. Again, width of the rectangles. Okay, and then we want to create something, and different I guess different textbooks, different people will do this a little bit differently. But really what this equation is going to do, x subscript k, sometimes you'll see x subscript I. The point of this is it's going to give us the opportunity to find what every endpoint is going to be. So in this case, we just want to be able to have a generic equation that represents the endpoint, because the endpoint at the end of the day is going to give us the height. So we can't have area unless we have height and we have a width. And each endpoint gives us the height. So we need an equation that represents every generic endpoint, every endpoint k. And so to find that, you start off with the beginning of your interval. That's always going to be the first number. So in this case, it's 2. So Liberty mentioned earlier she's been using summation notation. Same idea of summation notation. So you always want to find a function that represents the height, and then you have to find the width. Well, x of k is going to give us at least every endpoint, and then to find the actual function of that endpoint, you just plug it into the equation you're given, which we'll get to in a second. But you always want to start with the beginning of the interval, because we can't go left of that. We always want to go to the right of the beginning. And then you're going to add the width, which we established was 3 over n, and then times however many endpoints that's going to be, which we call k. So we don't actually know how many endpoints that's going to be. We just represent it as k. Okay, hopefully everyone's okay, can hear me and understand it so far. Now it's important, like I said, we can't just have the summation for just the width and what endpoints are. We actually need to find the height of all those endpoints. Well, to find the height of them, you plug them into the function. Because we want to find, if you imagine this picture, you want to find the endpoint, what's the dot on the line? That's the height. How high does it go? And to do that, you find f of xk. Let me just double check you guys can read this. Oh, no, I just realized that. All right. I'll have to go to, I gotta figure out this camera situation. I apologize. I was talking, maybe you're following along though. All right, so here's the work I have so far. Maybe this will make stuff a little bit clearer. I apologize for that. So this is, I'll give you a second. Take a look at that. That's kind of what I was just talking about. Not realizing that you guys couldn't see what I was writing down. So again, we got the Riemann sum from 2 to 5. That's what the goal. That's what we're looking for. The width is going to be found by taking the endpoints, subtracting them, dividing them by how many rectangles, how many shapes you're making. X sub k is going to represent each endpoint. So maybe I can specify that. Each endpoint. And then f of xk is where we're at now. So that's actually going to be plugging in x of k, or x sub k, into f. Well, if you guys remember the problem, they give us what f is. F is inside the function. We have the integral of f of x. So to find this, we're going to plug 2 plus 3 over nk into your actual equation, which is the square root of 1 plus, instead of x, it's x sub k. So plus 2 plus 3 over n k raised to the 4th power. Okay, and then to actually get your final answer, so we have the height. So this is your height. We know the width. The width we found earlier. So that's the width. The width is represented up there. So to find an area of a rectangle, right, it's width times height. So our actual summation, again, this is just the proper definition of finding an integral. So the limit as n approaches infinity. You'll notice every single one of your answers has that. Every one of your answers has k equals 1 to n. So now we just got to figure out what goes on the inside. Well, we have to first find the width, which we already did, was 3 over n. Now, which is nice because that eliminates 2 answers, right? B and D are the only ones that can be our answers now. And then from here, now we have that. We have to multiply by the height. So multiplied by what we just wrote. 1 plus 2 plus 3 over nk to the 4th. All right, and there's only one answer that matches that. So you guys can see D would be your answer there. So once you guys have that written down, everything, let me know just in the chat if that made sense. If you need anything else cleared up, I'm pretty sure if I remember correctly, 6 was very similar, except going backwards. Yeah, so 6 does the exact same thing except reverses the process. So you guys are going to be able to find, based off of the actual definition for the integral, how to get back to the integral. That's number 6. Okay. Richard said, hey, thank you. I got that now, I think. Okay, cool. And then Liberty said we got 6 with that logic. Okay, perfect. Sounds good. So I'll just stop, guys, just because this is a good time too. I'll go through the answers 1 through 6. So go back to your first one. Let's just see if we're okay, if I need to go anything from the previous problems. So number 1, you should have gotten D. To be honest, Lib and I don't remember doing anything like this last year. Yeah, I don't obviously know exactly what he taught. So there's a potential maybe he skipped over it or maybe he did it a different way. It's not too bad though. I think as long as you understand that this is the definition, you can find it in the book. If you guys would be beneficial, I can try to go in my book and find where it's written. But basically, I think probably the confusing part is finding the width, I would say, just remembering how to do that. Except that one's kind of, finding a width of a shape given n amount of intervals. It kind of makes sense that you would just take the endpoints divided by how many times you're taking it. But yeah, I don't know. If you guys want extra problems or you want to go over a little bit more, I can do that for you. Okay, so back to what I was saying. Hopefully you guys were hearing me. Number 1 was D. Number 2 was A. Number 3 was A. Number 4 was C. Number 5 was D. And then number 6 was B. Okay, so take a second, check that. Let me know if you need me to repeat any of them. Or all of them. I went kind of fast. Doing good so far. Okay, very good to hear. So you guys know we have about 10 more minutes. Things are, yeah, Calc. Liberty, it's the best class. I know, I get it. So I mean, first of all, I appreciate you guys being here. Hopefully it helps a little bit, at least so I can go over some stuff. And even if you don't need help, you have at least a resource if you do end up needing it. Out of curiosity, are you guys working together or separately? Separately and asking each other questions when we don't get some. Okay, we're doing the problem 7 check. Oh man, big word, Rachel. Discrepancies. Come on, I teach math. Think I know what discrepancies is? I hope I spelled that right. No, I'm kidding. I do know what discrepancies is. Good call. Good call. Okay, cool. I'm sure Hunter and Cole stayed up all night and forgot to wake up. So what I was gonna say is just the nature of how everything's going. Like, I'm not gonna be very strict with like due dates. At least for a while until we kind of get used to this pattern and kind of get used to things. So, like for example, I think this assignment I didn't even make a due date. I just opened it up. I'll still be checking periodically. I'll still be putting grades in. I trust you guys to get this stuff done, but don't feel like completely panicked or rushed to get everything done. I'll be here from, I don't know if you guys saw my Google Classroom message, but from 1 to 2, I'll be live in chat. So I'll just come up here and I'll just, it's kind of awkward if I'm being honest. I kind of just like sit here and wait for someone to say something, but I'll be here from 1 to 2. So if you guys have any questions from, the rest of the problems, please feel free to stop by and ask. Or if you just want to come through and check your answers before you submit it, that's also fine. So, whatever works for you guys. Just let me know. Also, feedback-wise, what do you guys think about writing on this hover cam and writing on the paper? I haven't tried yet writing on the whiteboard behind me, but I'm curious to see if, because I don't know, I kind of like the paper seems to work pretty well, but I don't know. Maybe you guys have a different opinion, so just let me know. I trust your feedback. I prefer the paper. Yeah, I think good. Okay, I think I would do too. Mostly because my handwriting is a little bit neater on the paper. And also you can see it more clear. Like my whiteboard's not very big, and my camera's somewhat far away, so I don't know how great it'll work. I might test it out someday and see how it is. But good. I'm just glad that you guys are okay with the paper. I just have to remember to switch to the camera so I'm not just talking and writing things down without you guys knowing. You know, as my stream grows, I'll get used to that. Speaking of which, I got 200 views on my video yesterday, but I don't know how. So maybe you guys have any clue. Like, how could I only have, I don't know, 80 students or something like that? Probably less, I guess, without study halls. So I'm wondering, it kind of scares me a little bit. Like, should I be worried how people, I don't know. Maybe you guys know. Maybe there's that many people really interested in learning all the math classes I teach. I got to imagine a lot of schools aren't as fortunate. Guess you're just real popular. Speaking of popular, Rachel, was it you who told Chad about me doing this? I'm minding my own business, and I see Chad Rich pop up in the chat. I was wondering. I was like, you know what? This has Rachel written on it. Oh, always a good time though. Really boosts my mood. But yeah, I don't know. So I don't know. But the issue is like, he's also YouTuber, so YouTuber. Oh God, I have to check that out. Yeah, but it just kind of I don't know if I should be worried just because I don't know the rules and regulations of it all. So that's the only thing that I'm concerned about. But maybe I can have like he was checking out the Rachel, what's he doing? I'm picturing what I would think he would do during a YouTube YouTube video, and like I could see him like being really obnoxious, or like maybe doing cooking videos. Actually, I changed my mind. I think he does cooking videos, cooking tutorials. It's like, hey guys, today we're gonna do top ramen. See how that works. I could see that. All right, guys, today we're gonna make some cereal. So first you put in the cereal, then the milk. Important distinction. That's how I'm picturing his YouTube channel looking. He vlogs. Of course he vlogs. He's wearing hydro dip shoes. Oh, okay, that's pretty cool. Yeah, I've seen him paint his shoes. Those are pretty cool. I don't know how he does it. Might be so bad if I tried, but he wants you to check it out. All right. I'll take a look. Don't put anything up here or any links or anything, but I'll take a look. I'm sure I can. I'll figure it out. I'm glad he's staying busy. Hopefully his schoolwork is getting done. Instead of painting shoes all day. But I'm glad he's being creative in his free time because he can't play tennis because he was going to play tennis. So. He wasn't going to play tennis, but I wanted him to play tennis. I was trying to convince him to. Looks like some AB students are starting to funnel in. Rachel and Liberty, you guys don't need to go. You can hang out, but in about 3 minutes, I'll be transitioning to AB, just so you guys know. Hopefully you have a good rest of your day. Hopefully everything's going well. Obviously, you can always email me if you have any questions. Kenzie, unfortunately. I love the optimism, Kenzie. I don't think you were here yesterday, right? So this will be your first experience with this stream. Kenzie, you can see on the paper there, that's stuff BC's doing right now, reviewing. You guys done that already. See you tomorrow. Maybe Cole and Hunter will join. Yeah, you guys got to convince Cole and Hunter to join. Because that's, you know what, I feel personally attacked by them, that they don't want to come and hang out with the BC bunch, which is what I'm marketing us as now. A little upset with that, but Liberty, the answers are 1 second. You said 7 and 8. So 7 was D, 8 was A. 7D, 8 was A. All right, 9:59. Heck yeah. All right, Liberty. Sounds like you guys are doing pretty good. That's good to hear. Kenzie, out of curiosity, did you watch the video yesterday that I posted to YouTube? Just be honest. You don't have to say yes or you don't have to lie, but just out of curiosity. No? Okay. If you ever need to, if you ever miss, I gotta put this in Google Classroom, but if you ever miss a stream, I'm posting them to YouTube, so you can just, the date you miss, you can check them out. You will today, though. Okay. Just so you know, Kenzie, it wasn't anything like content-wise. We went over some homework, so actually that could be beneficial to you, but most of it was just kind of talking about like the weeks to come. Liberty, when I finish this, can I just drop by your live stream and check those in? Yeah, absolutely, Liberty. If you mean by like if I'm doing other classes, Liberty, I might get your like answer when there's like a little lull. But at the very least, between 1 and 2, definitely come in and I'll go over the answers. Yeah. So it'd probably be better to wait. But if I'm not like if kids are just working on a problem and I'm just kind of sitting here like waiting for them to be done, then I'm more than happy to help out. Ethan, AB is greater than BC. I think Liberty would disagree, Ethan. Alright, I guess I don't need that paper anymore. Guess I can show you guys my face. Hey. All 11 people. I never know that number. I don't know if I'm considered a concurrent viewer, whatever that means, but there's 11 of you in here. So let me hear who's here. Let's hear see who's in the chat right now. There I am. Okay. It's 10. Calc AB time. AB time? Doc time? Ah, I missed that. Can't believe we don't get to hear that every day anymore. Andrew, Emma, good morning, hi. Beautiful morning today, very quiet. It's like overcast, just a nice atmosphere. Digidio, always good to see you. Jasmine, hello. Jonah, hey. Jonah, very dry greeting. Jonah, can you be a little bit more active? Give me something like emoji or something. Be a little bit more excited to be here. Morning, Stacklin. I can see. All right, Calc AB time. What's today's date? 3/17. 18:20. Okay. Morning. Top of the morning to you, Jonah. That's a little bit better. Still don't seem very excited. Great idea, you and Mr. Snook co-stream for a video. That'd be awesome, Jasmine. I don't know. I have no clue how we do that. I don't know if I'd have to we'd have to meet at the same spot or what we'd have to do, but that would be fantastic. It would be very entertaining video. I just spent 2 hours driving to stores to find toilet. Jeez. Sorry to hear that, Stacklin. And you still found none? Wow. I wish I had advice for you, but I don't. I didn't realize it was that horrible of a situation. But people are panicking completely. I don't know. That's kind of ridiculous to me. It's actually just kind of rude if you really think about it. I'm sorry that's the case. Maybe you could ask a neighbor. Maybe some neighbors have some stockpile left over. But I don't know why people's like first instinct during something like this is to like turn on each other. It makes no sense. Vinny says hello. Here. Vinny says hello. I don't know. Am I missing something? Do I know Vinny? Oh, the dog. I feel really bad if I had a student Vinny that I didn't realize. But tell Vinny the dog I said hi. Speaking of dogs, yeah, I agree, Kenzie. They are greedy and selfish. But speaking of dogs, I'm hoping maybe my dog can make an appearance. How great would that be? He's kind of like me. How do I describe him? He's an older dog, so he just kind of goes with the flow. Good boy though. I'll have to bring him on the stream sometime. Little Bentley. All right, about one more minute. We'll see who else pops in, and then we'll get started. Go grab it. Well, it's not with me, Ethan. It's at my parents' house, so I'd have to have him like come over, and then I'd be like a guest appearance, you know. Trust me, I would love to grab my dog. I would love nothing more. We can finally be in our class. Yeah, this is like now our 8th, 9th period of class, and it's not separate anymore. Steal your parents. I would love to steal my parents' dog. He's the man. Take a field trip. Yeah, Baron. Hey, Baron, how would I vlog me driving over to my parents' house, and then I could vlog like seeing the dog. That'll be our little field trip stream. Oh man. Okay. So guys, if you're new, I see a couple new people. I don't think I saw a couple of you yesterday. So just as a recap of what happened yesterday. So yesterday I took the stream. You can find it on YouTube. So if you're curious, I have timestamps. So you can see that you can see what we talked about and when we talked about it for your class. So the way I'm doing it again is I'm going to do BC in the morning from 9 to 10. You guys will be from 10 to 11. Algebra from 11 to 12. My office hour is going to be from 1 to 2 in person. So, and when I say in person, obviously I'm not coming to your house. I mean in stream. And then 2 to 3, I'm going to be doing just answering emails. So if you guys have any emails, I'll answer them. I'm pretty good about answering emails in general. If it gets ridiculous, obviously after 9 I can't at all. But if it's like if I'm not doing anything or if I'm home and I can answer it, like I'm not rude. If I see an email, I'll do it. So anyways, we talked about kind of what's the plan, what's going on. No one knows what's happening. The only thing that's for certain is that the next 3 weeks, this is what we're doing. So I want you guys to ease your minds. I want to make sure that we're still learning. I'm still teaching, and you guys can engage, and I can get feedback and figure out how we're feeling about stuff. So yesterday was all that, just covering that. Today I want to actually get into some content. So as a recap, it's going to be, my usual stuff. The way I usually handle things is right now I'd be saying like, all right, Ethan, what did we learn yesterday? Zach, what do you think? But, doing my thing. But it's going to be a little bit harder, especially with the delay in chat. So instead, I'm going to just kind of talk, which I hate, but I'm just going to kind of start talking and recap what we've been doing after this weird little break. So if you guys remember, we ended last Thursday. So both 8th period and 9th period, we kind of rushed a little bit, but 8th and 9th period, we both ended doing U-substitution. Now, the U-substitution was different because it was definite integrals. So we talked about using U-substitution with definite integrals. And we did 2 different methods. So if you guys remember, so if you haven't already, I should probably have led with this. Get out your notes. Get out like a sheet of paper. So start your notes. Like we're going to continue notes exactly where we left off on Thursday. So just pick up from there. I'll give you a second. So how about I just wait and then maybe some people in the chat just kind of say like good. So I have an idea. Everyone's ready to keep going. Good morning, Zach, by the way. So again, just picking up the notes where we left off. I have my notes out. Thank you, Stacklin. Good to know. While you're doing that also, guys, real quick, book. I made a post in your Google Classroom, and I said if anyone needs a copy of the book, let me know. So that's still up. If you guys, because I thought Monday maybe we could all grab a hard copy if we didn't have one. Thank you, Emma. So if you guys still need a virtual copy, I can do that for you, but just email me separately, and I can get you set up with that. Okay, cool. So everyone's good. All right. So in your notes, you guys will see we have a definition. So actually, let me see. I might be able to. I still need to figure out these hotkeys and figure this out, but bam. Okay. Not great because this is obviously my notes and I wrote them very, you know how I do things. But you should have had two different ways to solve. So you have one is by doing indefinite integrals and then using the fundamental theorem of calculus part 2. So just do the indefinite integral, just a generic antiderivative, and then replace u back with x, and then use fundamental theorem of calculus. That was your first way to solve. The second way was using this definition for 2. Now, the definition was basically just saying, like, do your normal idea. Do the same process. Do U-substitution, just like you would with an indefinite integral. The only difference is you have to change the bounds. So when we have definite integrals, if you see those lower bounds and upper bounds, so like example 1, 0 to 4. When you guys see that, 0 and 4 are with respect to x. So it's from x is 0 to x is 4. Now, we can't integrate using u and have the bounds be with respect to x, right? U is just this new variable that's defined that's a function of x, but we can't have an integral that has two separate variables being used. So to account for that, we can do u substitution, and instead of replacing back for x, we just change the bounds so everything's in terms of u and solve the problem that way. Now, 9th period, you guys didn't do both ways, I don't believe. I think I only showed you the one way because of time. 8th period, I believe we got through both ways. I'm not positive, though, actually, on that. So maybe, yeah, you guys give me some feedback. If what you got in your notes, I guess, because it's been a while. Trying to figure out how long this delay is. It looks like it's about good 15 seconds until you guys hear me. Maybe more, or maybe less, I don't know, because you guys still have to take time to type. We did, but quickly, yeah, I kind of figured as much. Kind of figured we flew through it. And at 9th period, I'm positive we didn't get through it. Donut break. Yeah, you guys can eat donuts. You can drink whatever you want to do. We only got through using U-sub, I believe. Okay. We only did U-sub. Okay. All right. So let me see. I'm trying to think of how I want to approach this. You guys have the definition down. Example 1, you can see I have up here. If you are watching this on YouTube, you guys might want to pause the video and maybe you can copy down what we have there. But I think maybe the best way to do it is kind of start fresh. So let's actually start with a new problem. So I'll give you guys a problem and I'll walk through the process of how we're going to solve this. So we're going to do it both methods as well. So this is just going to be in your example. I don't know what example you're going to label it as, but for me it'd be example 2. It's our second example, picking up from Thursday. Oh, let me lower that. Okay, example 2. All right, here's going to be your problem. So we have 1 to 2 of dx divided by 3 minus 5x squared. Now we want to solve that integral, so take a second, write that down. That's the integral we are solving. Now, hopefully you're looking at this, again, it's been a little bit of time, so you're looking at this, you're saying, okay, I have a 3 minus 5x in the denominator being squared. That's a composite function. You have a composite function, immediately U-substitution's got to be an option, so you have to think about it. Doesn't mean it's going to be the right option, but got to think about it. There's a 1 in the numerator. Now, that's a good thing for us because we always want to look at a difference of 1 in the powers of x. So if you look at the denominator, x power is 1, right? 5x power of 1. In the numerator, it's x to the 0 because there is no x. All right, and that's a difference of 1. 1 and 0, there's a difference of 1. So again, that's your second sign, U-substitution, very viable option. And so you got to think, okay, can I rewrite it? You can try, but no, you're not going to be able to rewrite this and get it any simpler. So U-substitution, let's try it. Let's dive in. But regardless of what method you choose, you have to at least do the U-substitution first. So we want to let U equal what's inside the inner function of the composite function. So 3 minus 5x. So that's what we're going to let U equal. You don't need the parentheses if you don't want. I don't know why I put those there, if I'm being honest, but that's okay. So U equals 3 minus 5x. Now, we want to take the derivative again. Regardless of what method you choose, you're going to need the derivative. So you need to take du, and you get negative 5 dx. All right, so derivative of negative 5x is negative 5 dx. Now, if you'll notice, in our problem, we're looking for 1 dx. Okay, so we want to somehow rewrite du so it's equal to 1 dx. And to do that, you divide by negative 5. Get rid of it. So you have negative 1/5 du equal to 1 dx. All right, now we're in good shape. Now we're in the position where we can actually use substitute. So I'm going to do each method. So this first time through, I'm going to just find the general antiderivative or the indefinite integral, and then substitute back in for x, and then evaluate using the fundamental theorem of calculus part 2. So let's start with that. I'm just going to write a generic integral with no bounds. I have a negative 1/5. Now, I want you guys to get used to this, so I'm going to do it now. Just take that constant out right away. So don't mess with it. If you ever have something like 2 du, 5 du, negative 1/5 du, negative 160, whatever it may be, just take that constant out. Don't worry about it. All right, because that's what it is. It is a constant. Just take it out front of the integral, and then we can multiply back in later. But if you don't have to deal with it, don't deal with it. All right, inside the integral, you still are left with a du. And instead of 3 minus 5x, we have u squared. All right, so that's going to be our new integral. Now, very, very important, and this is a crucial step in evaluating integrals in general. And we did this with derivatives, but I think students have a little bit harder time with integrals. Now, with derivatives, we'd always rewrite it so it's never a fraction. We'd always write it as a variable raised to a power. Whether it's negative or positive, we didn't care as long as it wasn't a fraction. So same idea. We want to rewrite this so it's negative 1/5 times the integral of u to the negative 2 du. All right, and then we're going to solve this integral, which is it's a basic antiderivative. So we have negative 1/5. You add 1 to the exponent, so you get u to the negative first. All right, and then you divide by that value. So divided by negative 1. So it's negative 1/5 times u to the negative first divided by negative 1. Again, we're adding 1 to the exponent. Negative 2 plus 1 is negative 1. I saw people, I remember from the quiz we took before you guys left, a lot of people accidentally subtracted 1. And it's a common mistake. It's an easy mistake to make. So just be very careful with that. And then if we go further here, this is going to be negative 1/5. Divided by negative 1 is going to just be positive 1/5. So positive 1/5, we're just going to change that to a plus. And then u to the negative first is just over u. So we can just put that in the denominator. So really we have 1 over 5u. And instead of u, we're going to replace that with 3 minus 5x. So again, we didn't change the bounds. So what we want to do is make sure that we just do in terms of x again. All right, so Kenzie said, wait, what? Kenzie, what step are you curious about? So 1 over 5u. Yes, 1 over 5u is correct. So negative 1/5 times 1 over u is basically what's happening. Why did you divide? Okay, so the reverse power rule, Kenzie, states that you want to raise the power of the exponent. So you raise negative 2 by 1. So negative u to the negative first. And then you divide by that value. So that's just reversing the power rule. That's just our definition, is why we divided by negative 1. Plug in 1 and 2 and subtract. Yes, Ethan. So we're going to get that right now. And this is how you're going to notate it. So if you guys see, we're going to notate this as this little line. It's just an up and down vertical line. And that means to evaluate it at 2 and 1. Basically, this notation says we're going to use the fundamental theorem of calculus, is what it's essentially saying. All right, so again, take the general antiderivative and then evaluate it at the bounds that you started with. So make sure it's all in terms of x. Common mistake is people keep it in terms of u, and then they get the answer wrong. So go ahead, take a second. See if you guys can evaluate that using the fundamental theorem of calculus part 2. Like Ethan said in the chat, just plug in 1 and 2 and subtract. That's exactly what we'll do. So you want to plug in 2 for x, get that value, and then minus plugging in 1 for x. Yeah, so Ethan, you're correct. It looks like you'll get negative 1 over 35 plus 1 over 10. You guys, we can simplify that further. Obviously, we'd get common denominator, or just put in your calculator. So I'm just gonna use my calculator just because I'm not too worried about our ability to. And actually, in an AP test, we can keep our answer like that, so we don't need to simplify. But just for the sake of neatness, we might as well figure out what that is, and it's 1 over 14. So 1 over 14 is the area under the curve of that function from 1 to 2. And let me get some feedback, guys, in the chat and see how we think about that method. So just our opinions, how do we feel, that good stuff. Looks like Ethan got it. Good. Oh, hey, Jade. I didn't know you were in here. Jasmine said good, good. Okay. Maybe one more minute, see if everyone else has any opinions. That makes sense. Is that Brian Harris? Always good to see you, Brian. How's it going? What a surprise. Hopefully everything's good out your way. As long as I didn't mess it up, I'm good. Yes, Josh, that would be the idea. This one was a little weird, but it makes sense. Yeah, it is a little weird. I'm going to show you the other method, which I don't know. I don't know what you guys are going to pick. They're both kind of pretty even. Man, it's good to see you, Brian. I bet you guys have. I don't even know if you guys have gotten to this stuff yet. I'm curious. We haven't even started this stuff yet. Yeah, that's what I kind of figured. Yeah, but Brian, hey, feel free to hang out and do some. You can get yourself ahead. I don't know what you guys are doing. I don't know if you're doing online school or what's going on with you guys, but yeah, if you wanna hang out and get some more get ahead of the game a little bit, feel free. That's funny. What a pleasant surprise. I still have my memorial chalkboard, just so you know, Brian. Still got the chalk bandit's mark. All right, so I want to do the same exact problem except the other way. So your option number 2, basically. So let me split this up. I think we should be good there. Okay, so same problem. Okay, so we still have that problem. Same idea. I'm just copying what I have earlier, so nothing, like I'm not going to really talk about it, but I'm just copying what I have earlier. So let u equal 3 minus 5x. du equals negative 5 dx. Negative 1/5 du equals dx. That's all stuff that we've been given to us, or that we've already done, I should say. Now this method is going to change two mainly things. So the idea is that if we're letting u equal to 3 minus 5x, then what we want to do is now find the bounds, the new bounds. Okay, if you notice, my bounds are 1 and 2. That's with x, but what about u? Well, we can find that. So at x equals 1 and at x equals 2, what does u equal? That's our goal. At x equals 1, x equals 2. What are our new bounds? Well, if you plug in 1 into u, you get 3 minus 5, which is negative 2. So again, I just plugged it into this equation. So this equation gives us what u is. To find our new bounds, we plug in what x is. So if at x equals 1, u is negative 2. At x equals 2, u is going to be negative 7. All right, so those are our new bounds. And that's how we're going to evaluate the integral now. So we're going to have, instead of from 1 to 2, at x equals 1, at u is negative 2, so we put negative 2 down here. At x equals 2, u is negative 7, so we put a negative 7 up there. All right, it's the exact same integration. So we still have u to the negative 2. We still have a negative 1/5 out front, du. Again, I just got all that stuff from the work we did previously. Same integration, same U-substitution step. The only difference now is our bounds are different. Which means when we actually take the antiderivative, we get positive 1 over 5u. So you guys can see we got that up here. We already did that work. And so now we're evaluating that between our new bounds, negative 2 and negative 7. And the nice thing about this method, or this way to solve this problem, is now we can just sub in those bounds. So if you guys notice up here, this problem wasn't too bad, but this composite function that back when we u-subbed back in, it's a little bit more complicated than just having a u, like a simple u I have down at the bottom. So this method might be a little bit easier math-wise. If you don't have a calculator, in my opinion, I think this could be a little bit of an easier option. Now, the same idea holds. We're still using the fundamental theorem of calculus part 2, but now we're just not switching the bounds. We're just keeping it in terms of u. So I have 1 over 5 times 7. Oops, 5 times negative 7. Apologize. And then minus 1 over 5 times negative 2. And if you guys notice, it's going to be the exact same problem as we had before. It's going to be negative 1 over 35 plus 1/10, which we know is a horribly written 1 over 14. So that's a little reminder of our two methods to do definite integral U-substitutions. And it's at the end of the day, it's for the most part, I shouldn't say this always, but for the most part, it's going to be your decision to make. Now, as you know, the way that AP works is they word these questions to design it so you have to choose one of the methods. And if I'm being honest, generally the method they want you to do is this one down here. That's generally, from what I've seen, it seems like that's the one they want to test you on, to make sure you understand and change the bounds, because it's a little bit tricky. So Jaden said he liked the first method. Okay, and I understand that. We got to make sure we know both methods as much as you maybe like one or the other, because there's the way certain questions are designed, and you guys might see this at some point, but it'll force you into using one or the other. And like I said, it's generally using the second version. So I want to make sure we're okay with that. And I think if I'm going to pull up the calendar real quick, but I believe maybe we have an assignment later in the week that's going to show that. My MacBook was not designed to stream, I'll tell you what. Let this load. Okay, yeah, so tonight's homework, you're going to have a college board. That assignment will have some problems that make you use that second method, Jaden. Jaden said, are your tests going to let us choose which method we want to use? That's a good question, Jaden. First of all, with tests, I really don't know if there's going to be any tests in this class. All right, so it's kind of hard to say. Unless we get back into school, then it'll be a little bit different. But where I'm at right now, probably I'll probably let you choose. But again, just like College Board, I might design a question where it would say, hey, the only way you can solve this problem is if you use the second method. So you got to be careful. I want you to use both, Jaden, is what I'm trying to say. Eden said you have to get an Alienware computer to stream. I don't know what that is. I'm assuming that's like a hard, like a actual computer, not a laptop. Kenzie said, thank God. I don't know what that was referencing. Probably tests. Yeah, you're right, Ethan. I do need to get, that would be beneficial, but I want to keep everything together on my school computer because this is where I have everything. So even though it's not efficient, it's okay. How's the feedback? Are you guys getting any buffering? Is the stream coming in all right? It's a gaming computer. Yeah, that's kind of what I figured, Brandon. I just have that for when I game. This is more for the educational part. Yeah, so just let me know if you guys, how everything's on your end. If you can hear me, if I'm too loud, if I'm too quiet. If you can see everything okay, if it's not buffering the whole time, if the resolution's all right, all that good stuff. Brand said, yeah, it's fine. Ethan said, can we do a trig problem with sub? Yeah, sure, Ethan. I haven't had any buffering. Yes, on buff. Okay, occasionally. I can deal with occasionally. It's all good. Okay, cool. All right. How do you guys like the notebook? What we're doing with the notebook? Is that working for you? I feel like, based off of my test, I feel like this is going to be better than the whiteboard. I'm going to fly through paper, I'll tell you that, but I think this might be a little bit of a better option, personally. Yesterday the audio skipped a little, or it would pause for a second. Okay. Yeah, Stack. I kind of figured I had a little bit of issues yesterday. I think my stream actually cut out for a second. So if it ever starts being really bad, you can always X out and try to log back in, or you can always wait. I will post the video at night. So actually not really at night. I'll post in the afternoon. You guys can just see that section pretty quickly too. So you have a couple options. Sometimes it helps to change the resolution that you're watching the video at too. You guys are good with this stuff. You can figure it out. Okay, so Ethan said he wanted to do a U-sub with trig. So let's check this problem out. Okay, so we have the integral from 0 to the square root of pi of x cosine x squared dx. I'll tell you what. Let's have you guys, I'll give you like 5 minutes. So go through that problem. And I want to challenge you to use the second method. So I want you to keep it in terms of u entirely. So change the bounds in terms of u. That's my challenge to you. So go ahead, take about 5 minutes, see if you can go through this problem. and I will sit here patiently, awkwardly waiting. All right, so you can check your work at least for the first step. If you didn't know exactly what to do to start, you can at least check there. Just remember, we have a composite function. So cosine of x squared is of two functions. X squared is the inner function. So we want to think U-substitution. We have a difference of 1 in the powers of x. So the x out in front of the cosine is to the first power. The x inside the cosine is to the second. So that's a difference of 1. All of these are leading you to think U-substitution. Always make U equal to the inner function, in this case x squared. Take the derivative, you get du equals 2x dx, and then divide by 2 to get x dx. Ethan, I'm not sure yet. I will get there, but yeah, guys, if you guys want to put your answer in, so I can kind of see some feedback, I'll once I work out the problem, I'll let you know. Zero, no idea what is in terms of pi. I'm using a computer calculator. 0, 0, 0. Okay, so people are getting 0. Okay, so just so anyone who's still working or maybe stuck, we want to get the bounds changed. So we want to figure out what's happening in terms of u. What are the bounds in terms of u? So when x is 0, u is 0. When x is square root of pi, u is pi. So our new integral becomes 0 to pi of cosine u du. All right, and then we take our general antiderivative. So we're going to have sine of u between 0 and pi, or in the interval 0 to pi. Okay, so the antiderivative of cosine is just sine, because the derivative of sine is cosine. So remember, you can always flip back and forth between those. Okay, and then we have our bound 0 to pi. And now we just got to evaluate using the fundamental theorem of calculus. So we have sine of pi minus sine of 0. And if you notice that the y values for both of those at 0 and at pi, again, unit circle, got to be able to use unit circle, it's going to be 0. Sine of pi is 0, sine of 0 is 0, so your answer is 0. Ethan, if I had to guess, maybe you were using a computer calculator that was in degrees, potentially. That maybe got you your weird answer. But your final answer should be 0. Where did the 1/2 go? Ah, good point. Thank you, Kenzie. So I should have also carried the 1/2 down as well. So that should have been 1/2 of that, and then you should have 1/2 sine of u, 1/2 sine of pi minus 1/2 sine of 0. I know I wrote that very messily, but the 1/2's not going to matter because those both turn into 0. So it's going to be 1/2 times 0. But thank you for correcting that. Ethan said didn't make it sine. Okay, yeah, so make sure you take that antiderivative before you can evaluate. Alright, and that's the problem. And like I said, you guys didn't have to necessarily do it this way. You could have also, well, I told you to do it this way. Let me rephrase. I did have you do it this way. But there is the other method, and you would have got the same answer. So if anyone was curious, you guys can go back, or if you're watching this on YouTube and you want some extra practice, this is your answer 0, so you can go back and do it the first method and see if you get the same answer. So it'll be a good little test. See how you're doing. Maybe some feedback in the chat. How are you guys feeling? You want another type of question? Because this is what we're doing today, so I'm just going to go through problems. Anything that you guys need to look at specifically, try to find a problem that matches up. If you want to do indefinite integrals, definite, however you want to do it, let me know. So just kind of give me some feedback in the chat like Ethan did, and we'll go from there. Chain rule question with U sub. Chain rule question with U sub. Okay. Chain rule question with U sub. Agree with Ethan. Okay. Let me see. Give me a second, guys. Let me see if I can find one with the chain rule. Because U-substitution kind of accounts for the chain rule a lot of the times. So let me see. I'm sorry about that. I'm still looking. See if I can find anything. Okay, maybe this one. So let's do from 0 to pi. So the integral from 0 to pi of secant squared t over 4 dt. I don't know if this is going to end up being a chain rule or not, but it's still a good problem. So again, I'm going to let you guys decide. I don't have a preference on how you do it. So you guys choose what method you want to do personally. And if you're on YouTube, just pause it. Try to work through the problem your way. You guys in the stream right now, go ahead and dive in, see what you can do. Okay, so I have the first one set up there, or the first steps. So the U-substitution part, and then the replacing the integral with U. I'm going to use the second method, I think. Or sorry, the first method for this one, because I did the second last time, so you guys can see that one now. So from here, what I want to do is I'm just going to take the general antiderivative. So I should have made my decision on what I was going to do beforehand, but you can cross out the pi and the 0. So I'm just rewriting it now. We want to take a general antiderivative of that. Well, the integral of secant squared u is going to be tangent. All right, so for tangent of u. So the derivative of tangent is secant squared, so that means that the derivative, or the integral of secant squared would be tangent. And I'm going to replace u, so I'm going to have 4 tangent of 1/4 t between 0 and pi. Oh, sorry, I just saw your chat, guys. Okay, wait, so definite. I agree with you. Why does t become 1 and not x? Why does t become 1? Yeah, shouldn't t be x? Okay, I think I understand what you guys are saying. So the problem gives it to in terms of t. So we're not actually in respect to x. So our bounds are in terms of t, our functions in terms of t. We're taking the integral with respect to t. So since everything's in terms of t, we're basically just replacing, like we're not doing this problem with x, we're just doing the problem with t. Hopefully that cleared it up. But just like, when you're doing math problems, I can tell you 3w plus 5 equals 6, and you can solve that for w. Same idea. T is just a variable. It doesn't represent time, it's just a variable. So Brandon and Ethan, I understand we're comfortable with x, but the variable is not always going to be x. So just let me, hopefully that makes sense. Let me know if I was clear with that. So bounds won't change. Yeah, exactly. So doing the first method, we're not going to change the bounds because we're replacing it back with t. If you were doing the second method, if you decided to do the second method here, then you would change the bounds, but it's your choice. So I'm just doing the first one. Okay, and then we're going to get 4 tangent of pi over 4 minus 4 tangent of 0. So I think everyone, okay, so Ethan said that works. All right, good. So you're going to get 4 minus 4 tangent of 0 is 0, so you're going to get 4. So your final answer should be 4 for that. So the area underneath the secant squared of t over 4 curve between 0 and pi, the area is 4. So you guys hear me after every problem, I'm going to keep repeating that because it's important we understand what the integral is for. Why are we doing it? And we're doing it to find an area underneath the curve. All right, so maybe a little bit of feedback, see how that works for you guys. Give me a couple thumbs up, how we're doing, whatever. If I missed something, if I messed up, that tends to happen, so I'm used to it. Man, this must be pretty delayed. Unless everyone's just ignoring me, because that would make sense too. Either way would make sense to me. Will we ever see a problem where we are not given the equation to find the area under the curve and we have to find the original equation ourselves? No, Ethan. Good question. You're not going to have a problem where you actually have to find, like, if I think what you're asking is, like, given the bound 0 to pi of something, what was the original function? No, that's not going to be a problem. We're going to be given. You might get a problem where you have to, like, go back and forth between derivatives and integrals. But we'll kind of attack those problems when we get there, if we get there. So for now, though, it's a good question. I don't think you'll have to worry about that. Okay, so no comments. Either it's on a crazy delay or you guys are just ignoring me. Shame, shame, shame. That's okay. I think we should have time for one more problem. So I'm assuming that we're all good. Let me see what kind of problem we can do now. Oh, here we go. All right, there's some feedback. Stacklin says, okay, Stacklin, we'll do another problem. Maybe this will help clear it up a little bit. Haber says, good. Man, this must really be on delay. That's all right. Okay. Here we go. This is a fun one. This will be a quick one. I think this is our fourth example, maybe? I don't remember. Ken said I have to leave, unfortunately, but I'm good on this. Thank you, Kenzie, for letting me know. Have a good day. Okay, guys, this will be the last problem we do today. So the integral from 0 to 2 of the function x minus 1 to the 25th. Whichever method that you feel less comfortable with, try it on this problem. So in about 2 minutes, I'm going to start going over this. So if you're on YouTube, just fast forward 2 minutes. I'm getting better at that, just assuming some people are watching this on YouTube. Saving them a little bit of time. That's what calculators are for, Ethan. Okay, I'm going to get started on this. So I'm going to use the method where I replace the bounds. So I want everything in terms of u. So I'm going to let u equal x minus 1. Du equals dx. Good shape for me. At x equals 0 and at x equals 2, what's happening with u? So at x equals 0, u is going to be negative 1. Again, I'm just plugging it into this equation. I have an equation for u. If I want to find what u is when x is 0, I plug in 0 for x. Okay, now at x equals 2, it's going to be 2 minus 1, so u is going to be equal to 1. Pretty easy math there. my new integral becomes -1 to 1 of u to the 25th du. All right, now from here I'm just going to take an antiderivative. So I'm going to take u, raise it to the 25 plus 1, which is 26, and divide it by 26. Again, that's just reversing the power rule. And we're evaluating that between -1 and 1. So I end up getting 1 to the 26th over 26 minus -1 to the 26th over 26. Notice I put a parentheses around -1. I did that very strategically because remember, when you raise -1 to an even power, it's going to turn positive. So if you put in your calculator it's just -1 to the 26, it's going to be a negative number. It's going to be -1. So you got to be careful with how you put in your calculator. So I just write it very carefully so I know that. And what you end up getting is 1 over 26 minus, this turns into a positive 1 over 26, which ends up being 0 again. Jonah says amazing. Oh, thanks, Jonah. I don't know if you're talking about me or the problem, but I appreciate the gratitude. Jaden said, can you do it the other way? Yeah, do you want me to go over it the other way, Jaden? That's fine. Let me see back. Okay, just put it up a little bit. So Jaden's, and anyone, I guess, who's curious, the same thing as before. We're just going to do a general antiderivative of u to the 25th. So this is your second way. So let me just kind of cut that off. This is going to be your second way. I skipped a couple steps, guys. Remember, all the steps are the same. The only difference is we're keeping the bounds and we're replacing u back with x. So I'm still going to get u to the 26th over 26. And that's going to be equal to x minus 1 to the 26th over 26, evaluated between 0 and 2. Sorry, I'm starting to write kind of small. So the quantity x minus 1 to the 26 divided by 26 between the bounds 2 and 0. So this is going to end up being 2 minus 1 to the 26th over 26 minus -1 to the 26th over 26. And you'll see that's the exact same problem as before. So you'll still get 0. Ethan said, smashing that like button for the... Thank you, Ethan. You know, people don't like this stream enough. I need more likes. Stack on... I had 3 dislikes, I think, on the other one. Unbelievable. I'm just putting my heart and soul into this stream, and you guys are just disliking my work? Can you imagine? All right, that's today's stream. Dislikes only. Stackland, stop with your propaganda. I don't like that. More bonus points off. Well, that was today's stream, guys. Thank you for attending. If you're on YouTube, hopefully you enjoyed. You can always email me if you have any questions. I will be here from 1 to 2 live for my office hour, and then from 2 to 3, I'll be answering any emails you guys have. I made a comment in Google Classroom. If you need, if you want a special kind of, if you need extra help, just email me. Let me know, like, hey, Mr. Harris, you might hang out just a little bit longer, and so we can go through some problems. Just let me know, and I'm willing to do that. Mr. Harris has officially turned into YouTube asking for likes and all that. Yeah, Brandon, you know, I gotta do what I gotta do. You know, you gotta market yourself, and part of marketing is smashing that subscribe button. Turn on that bell. It's one click, just one little click. I'm not asking much, not asking a whole lot out of you guys. That's all. Like, comment, subscribe. Don't comment, though, because I'm not going to look at them. If you want to talk to me, you can email me. Yeah, so, guys, your homework tonight is College Board assignment. I will, if it has, actually, it's already been assigned. I believe I already opened it up. So, you guys can get started on that. Thank you for attending Calculus AB. Looks like based off of Michael and Jaden hopping in, it looks like Algebra 2's joining the stream. Best part of your day? That's what I like to hear, Michael. When's the merch coming out? Well, Jaden, I'm working on it a little bit. I'm trying to figure out what my brand's going to be, Jaden. I think something to do with, just off the top of my head, maybe math. Maybe like some math equation, perhaps. Pythagorean theorem could be my brand. I don't know. I'll figure it out. You're welcome, Jonah. Okay, good stream, Mr. H. See you tomorrow. Okay, Brian. See you tomorrow. Liberty, what are 9 and 11 for our assignment? I can come back for office hours, problem 10. Okay, Liberty, give me a second. See you, Brandon. Morning, Jaden. Molly, love the excitement. Okay, so Liberty, 9 is B, and 11 is C. Mr. Harris is looking for those sponsors. No, I'm really not, actually. I just find it very, very entertaining to act like I'm doing this like for a profession. Because, I guess it kind of is now, but it's really, you got to understand how awkward this is for me. Good morning, Sarah DeGidio. Brandon and Sarah hopping in the chat. Alright guys, I'll give it about 3 more minutes to let people kind of flood in here. Looks like I got 16. I don't know who's still here for calculus, but about 16 it looks like. Morning, Jared. You had over 191 views. Yeah, Michael, I don't know, maybe how the heck does that happen? Like, I'm not really, this is my first time doing this, but unless people are like Googling or YouTubing like help with calculus or something like that, I don't see why mine would pop up. Oh, Liberty, you're killing me. 12? So yeah, Michael, let me know. Let me know in the chat why that's happening, because I'm curious. Liberty number 12 is D. You're good. It's just Michael watching it over and over again. That'd be awesome. Just trying to get those numbers up, Michael. I appreciate you. You're welcome, Liberty. Okay, guys, about a minute more, and then we will get started. So you guys who are in here right now, get out your notes and then your textbook. So let me see, actually. Oh, darn it. I forgot to take one home. Okay, it's going to be a little slow for me because I gotta open up the online textbook. So give me 1 second, guys. Morning, Aiden. Good to see you. When people look up help, the first thing that pops up is people that are live or newer content. Okay, I got you, Michael. That makes sense. All right, let me get my. So yeah, guys, open up your textbook. Get your notes out as if this was like our normal class, and we're going to be on 7.4. So in your books, chapter 7.4, page 478. Is it really? Thank you, Molly. Should I have breakfast, guys? My first period knows all about my breakfast habits. It's not good habits. I gotta start eating breakfast. I'm hungry right now. What page? Jaden, you can read. What page? Molly Wade was so kind. So guys, my book, because the MacBook was not intended to be streamed on, my book's pretty slow. So just bear with me a little bit when I'm trying to like load stuff. You and your mini muffins, LOL. Yeah, Sierra. That's my go-to. What can I say? I love my mini muffins. But recently it's been Cliff Bars. That's what I've been sticking with. Turn this into a cooking shoe. Isaac, I don't know if I've ever seen a cooking shoe. I don't know what you mean. I know, I'm just kidding. Coffee is the best breakfast. No, it's not, Molly. It's really not. Coffee's great and all. Like I survive off of it, but you know, it's not always the best. Not always the best thing to be drinking. Okay, turn this into cookies. That'd be hilarious. Nick's here. Good to see you, Nick. All right, yeah. So guys, page 478 is where we will be at. Now, usually I'll ask you guys questions, and I'll kind of be like, "Hey, Michael, what happened? What were we talking about before? Hey, Digidio, what do you think?" And you know, that's how I usually handle this stuff. But due to the circumstance, I'm gonna I don't want to wait because there's a little bit of delay between the streams, so I don't want to wait like a ton of time. So I'm just gonna kind of talk for the next couple minutes. So just hear me out, guys. Put those headphones in or whatever you're listening to, and just kind of absorb what I'm saying here. But before I start, Sierra said pancakes are good, which is so true. And Jaden, thank you for being nice and respectful. I appreciate that. Okay, so let's get started. Today's lesson. So if you guys have your calendar, we should get that out. Open that up, and you guys can see what's on the agenda today. So I'm going to spend like the last 10 minutes ish discussing the homework, which we'll get to. But you guys are going to have book page homework. Now, I've never done this on Google Classroom before, so I really have no clue how it's going to work, and I don't really actually know exactly how it works. As far as I know, though, what you'll be able to do is you will be able to do this homework assignment. So you have all day, obviously, today to do the homework assignment. And then it's page 480, 8 through 19 odd. It shouldn't be very long, not too much work. After you guys are done with that, I have in Google Classroom, it might already be up, an assignment. So an assignment will pop up, and it will say page 480, 8 through 19 odd. There, you guys should be able to turn in or submit an attachment. All right, and that attachment will just be a picture of your work. So whatever work you did for this homework, just take a picture of that page or 2 pages, whatever it may be, save it, and then email it to yourself or whatever you have to do. Or you might be able to just do it on your phone and just upload an attachment to Google Classroom. So if you have the app, I got to imagine, you can take the picture, you can go to your Google Classroom and then just attach it from your phone, I would guess. If you have to use your computer, maybe emailing it to yourself would be the best option. Or if you have like Google Cloud or iCloud or something, you might be able to kind of like just get it from there. I'm not really sure. You guys are smart with that stuff. You'll be able to figure it out. But yeah, throughout the day, if there's issues or if you have any suggestions, please feel free to email me or reach out to me so I can make adjustments. Because like I said, I haven't done this before, so I don't know if it's going to work. I can send it when I'm home, but that will be in a bed. That's okay, Tanis, no problem. It's not going to be due like by the end of the day, so this homework will be like ideally, get it done. I think I set the assignment due for tomorrow at 3:30, like the usual stuff. So yeah, this is kind of like a test run. I want to make sure that we're doing okay. As a reminder, guys, your grades. I'm still going to be updating your grades. So the assignments that you miss will still be being counted as zeros in Google Classroom. Or Power School, I mean. And I know some of you guys who are actually in the stream right now, some of you guys didn't do the Khan Academy. So those of you who didn't do the Khan Academy, make sure I still have it open because I understand this is kind of a weird situation. So because it's a weird situation, I still have it open, and you guys still have the opportunity to complete it. I need you to let me know if you complete it so I can update your grade. But I need people making sure they're engaged, because if you don't do anything the next 3 weeks, you're going to probably fail the quarter. So keep that in mind. And that's not a threat. That's just I want to make sure that we're very aware of the situation. Michael said we can just mail it to you. Yeah, but I don't know if it's a joke, like you mean like mail, like physically mail it to you, because that's not happening. But I also don't want you to email it to me, because that's gonna be like really, really hard to go through every single person in Algebra 2's emails to try to find the assignment. But if you meant like as a joke, yeah, let's not do that. Jaden said, if you take a pic on your phone, use your phone charger to download. Yes, yeah, Jaden, good point. Definitely, yeah. If you do take a pic on your phone, use your phone charger. You can download to your computer, and then you can upload it. All right, Michael, yeah, that's what I thought. So Jaden said, where do you want us to attach the photos for your homework? There should be, in Google Classroom, there should be a tab that says assignments, and there should be an assignment posted that says page 480, 8 through 19. I think you can just click on that assignment, and then there'll be a place to attach it there. That's what I think. Like I said, I'm not sure. So Sarah said, if you click link attachment. Okay, so it should be pretty self-explanatory from what I understand. Just let me know, though. But for right now, I just wanted to address it in case I forget at the end of the stream, and while everyone's still here. So yeah, you guys will have that opportunity to do that later. Nick said enunciate. Okay, Nick, we'll address it at the end of the class. I'm gonna get started with the lesson. So if you guys look in the calendar, we are gonna be doing 7.4 notes. Happy St. Patrick's Day, Aiden. I forgot it was. Oh, I should have wore like a man. Wish I would have known. I would have wore like some St. Patrick stuff. That'd been funny. Little what should you call it? Like a theme stream. Oh, I wonder if I'm the first one to think of that. That's awesome. All right, will you be looking at every assignment, Molly? If I assign something to you, yes, I'll be looking at it. But no, not every assignment I'll ask you to upload to Google Classroom. Hopefully that clarifies. Only specific assignments I'll ask you to upload. So basically, I'll be only looking at specific assignments. For example, tomorrow night's homework, I'm not going to have you post to Google Classroom. It's going to be more so like, it's a trust system. I just have to trust you'll do it. Isaac said, quick change, yeah. There's no assignment link placed to put our photos. Okay, again, Jane, let me get started on the lesson, and then at like 11:45, maybe we can mess around a little bit with that. Okay, does that sound good with everyone? Can we get with that? Get on board with that? Okay, so let me see. Actually, I'm going to change my camera real quick to this camera. Okay. All right, so you guys should be looking right now at the book, my book. And this is where you want to be at, solving logarithmic equations and inequalities. So make sure that's the page we're on, 478, and we're going to get started. So unfortunately, I'm going to have to do a lot of the talking, but that's okay. I'll get used to it. So the top of 7.4, it says why. So I'm going to read this little paragraph up here, and we'll take a look at what's going on here. So it says each year the National Weather Service documents about 1,000 tornado touchdowns in the United States. The intensity of a tornado is measured on the Fujita scale. Tornadoes are divided into 6 categories according to their wing speed, path length, path width, and damage caused. So I don't know, that kind of surprised me a little bit. 1,000 tornado touchdowns? I would have thought less. I don't know about you guys, but you don't really think about that many tornadoes. And I think a lot of times they're, lower on the Fujita scale, so it doesn't do a huge impact. It's probably why you don't hear about them. But that's kind of a lot. That's a lot of tornadoes. And so they kind of just talk about, they give you the different wind speeds and the different scales and the type of damage that it can do. Now, you'll see later on in the lesson how this kind of can relate to what we're doing with the logarithmic equations, but, something interesting to learn there. Let me actually make this full screen. So I'm not going to see your chat right away. Book always have a hard time with this. Okay. So number 1, it says solve logarithmic equations. A logarithmic equation contains one or more logarithms. You can use a definition of a logarithm to help you solve logarithmic equations. All right. So first step, not too bad. And this is kind of what we're going to lead into. So if you guys remember, Thursday we did logarithmic equations. You guys did your Khan Academy over the weekend. And the main idea was just rewriting exponentials and logarithmics. So our goal over the last week, the end of last week, was we just wanted to, how can we go back and forth between the two? How can we go from an exponential equation and then say, you know what, I want to write a logarithmic. How can we go from a logarithmic and write an exponential? So the first example we're going to look at to solve logarithmic equations, we're going to be doing with the intent that we're going to write it as an exponential. So we're going to change from a logarithmic to an exponential and then evaluate from there. All right, that's the goal. That's what we're planning on doing to start, and it's not too bad. So this is gonna be a good review. So this is where we'll start. All right, and you guys should still be seeing this screen. So let me switch over to my hover cam. So if you guys want to title this, what I would do, make sure this is actually okay. A little bit. So what I would do is just title it 7.4. Logarithmic equations, or solving logarithmic equations, however you wanted to title it. And we're going to look at example 1. Even though it's in your book, I can still kind of talk about what we got going on here. Okay, so write that problem down. Log base, so let me remind you guys, when we're saying these, even though I can't hear any of you talk, hopefully in your head you're having that little self-dialogue, right? Log base 36 of x equals 3/2. Base 36 of x equals 3/2. We want to just solve, so we're solving that logarithmic. We can't just put this in our calculator, right? We don't have a calculator that we can just put in log base 36x equals 3/2 and it gives us the answer for x. So we do have to manipulate it, so you do have to do at least that step. So what we want to do from here is rewrite, so x stays on the same side. So we've worked on this before, where we've had x on the same side. Our base, b, goes to the other side as the exponential base. So our base there, 36, is now our exponential base. And then the other value, that y value, 3/2, is our new exponent. So you take that and move it up to the exponent. We've been doing this quite a bit, but this is a good little refresher. All right, now from here, if we have a calculator, right, we can just solve it. Not too bad. We just plug in 36 to 3/2. Let's look at, though, kind of how they do in the book, where they say, well, let x equal, and we've talked about with exponentials rewriting bases. So instead of it looking at it as 36, we can look at it as 6 squared. So x is equal to 36, or x is equal to 6 squared to the 3/2. Now think to yourself, okay, I have a base raised to a power that's raised to a power. I want you guys to remember what happens when you raise a power to a power. All right, and hopefully you're thinking, well, we multiply those numbers. So you multiply those values together. Meaning x is equal to 6, 2 times 3/2, the 2's will cancel. So you'll be left with 6 to the 3rd, or 6 cubed, which we call power to a power. And 6 cubed is 216. Okay? So really not too much new, not too much new with that problem. This is kind of the basic type of logarithmic equation of solving one, where x is x, where we have a base and we have an opposite of the y value and we want to solve for x. Okay, so what I want you guys to do, just like we would in class, I want you guys to try 1A and 1B. So take a minute. I'll give you some time because I know this is on a delay, so I have to be extra patient. But take a minute, do guided practice 1A and 1B, and then let me see some answers in the chat. So once you get both of them done, I want you guys to put your answers in the chat so I can kind of gauge where we're at, how we're looking. Michael, double check your work with that one. Jaden, good job. Let me see if you can get some values. Let's see if we can maybe get exact answers for those. So you guys feel free to use Desmos to plug that in, however you want to do it. 27, 20. Yeah, good. Nice. Okay. Now I never know like if you guys are just looking at what everyone else is saying, but I trust that we're doing all right. 27. Okay. Blake, scroll up in the chat. You'll find it. It's 3 to the third. Okay, so let's take a look. 1A, I'm getting a couple different answers. Yeah, Michael. What Michael's comment, I think, is what other people are doing. Remember, 9 is 3 squared, not 3 cubed. I think some people are thinking 3 times 3, so they think 3 to the third, but that's different than 3 squared. Nick, very good. All right, Jaden, good job. Okay, so it looks like 1A, we got a pretty good feedback. I'm going to start writing how to do it. And then you guys can check your work for 1A and 1B. So 1 capital A. Let me make sure you guys can see my paper. Move it up a little bit. Okay. So 1 capital A. All right, so first things first, to solve a logarithmic equation, we have to write it as an exponential. So our base 9 becomes our base of our exponential, raising it to the 3 halves. Which means x is equal to 3 squared to the 3 halves. So I think that's where I think Michael made a comment. People were putting 3 cubed instead of 3 squared. Remember, 9 is just 3 squared. And now if you multiply 2 times 3 halves, you get x equals 3 to the third. And 3 to the third is 27. 3 times 3 is 9. 9 times 3 is 27. All right. Now let's look at 1b. So x is equal to, we're going to rewrite this as exponential. So your base is 16 raised to the 5 halves. So x equals 16 raised to the 5 halves. We can rewrite this as x equals 4 squared to the 5 halves, because 16 is 4 squared. Multiply 2 times 5 halves, and I get x equals 4 to the 5th. And I would imagine most people don't know that from the top of their heads. I know I don't. So use your calculator. 4 to the 5th is 1,024. All right, so take a second, look at that. So let me know if that looks okay, if you have any questions on that. Damon said, but where is the 3 cubed coming from? There is no, the 3 cubed, okay, I see what you're saying. So you're saying, Damon, this 3 cubed. Okay, so that 3 cubed is coming from 3 squared to the 3 halves. When I raise 3 to the square to the 3 halves, you multiply that. So if I do, multiply 3 halves times 2, you can see the 2 cancels, and I'm left with just 3 over 1. So that's where that exponent is coming from. 2 times 3 halves. Okay, and then 1b was 1,020, 1,024. All right, I think we're okay. Very good. All right, let me go back to my face in camera. All right, so now we can see the next part says we want to use the following property to solve logarithmic equations that have logarithms with the same base on each side. Now, I don't need you guys to necessarily copy this down. Okay, so this is our key concept. I'm gonna actually make this full screen. So this is our key concept here. If b is a positive number other than 1, then log base b of x is equal to log base b of y if and only if x equals y. So if you guys remember, when we solved exponential equations, think back. Take a little time travel back to solving exponential equations. When we were doing that, our process was we made like bases. So if we had something like 3 to the x equals 9 squared, we would rewrite it as 3 to the x equals 3 squared squared. Okay, and then when we have the same bases, all we had to do was set the exponents equal to each other and solve. Because if they have the same base, the only way that they can be equal to each other is if their exponents are the same. All right, now that's review. That's stuff we've talked about. This idea, this key concept is the exact same thing. If you have a log with the same base, whether it's 10, 5, 2, whatever it may be, if you have the same base and you have a log, then what's inside of the logarithms has to be equal. That's the only way those can be true statements. Because if you look down here, if x does not equal y, these can't be the same. Right? These will be completely different numbers. If I type in log base 6 of 5 and log base 6 of 7, those aren't going to be equal. So if we know we have the bases are the same, then we just set our inside of the log the same. So x equals y. So that's where they get this if x equals y. All right, and then their examples are this down here. If log base 5 of x equals log base 5 of 8, the only way that's true is if x is 8, or x equals 8. All right. Again, very, very similar to exponentials, and where it makes sense, because logarithms are just inverses of exponentials. Okay. So I think this is actually an interesting problem. I usually don't do these too often, is the standardized test examples. You'll see on this page here. But I kind of like this one. And I don't know if I'm going to do it the way they do it, just purely because I want to, actually, yeah, maybe I will, but we'll see. But let's try this problem here. So let's use that key concept, and let's try to solve this problem. So let me go back to my notebook. I gotta get some hotkeys to make that a little bit easier, but I haven't figured out which ones to put, because I originally had it as like 1, 2, and 3, and then I found myself typing in 1, 2, and 3 all the time, and it would change my camera without me knowing. And then I'd be like going over an example, and people would be like, "What you doing, Mr. Harris?" So I'm gonna have to figure out a solution to that. That's okay. All right, so here's your problem. This is going to be example 2. So we want to solve log base 2 of x squared minus 4 equal to log base 2 of 3x. All right, and you guys can see this is a little bit more complicated. A little bit more complicated than before. Tanis said just put them on it. Oh, it's so smart. Thank you, Tanis. I didn't even think about that. That's a good idea. All right, so that'll probably help me out a little bit. Can't believe I didn't think of that. Yeah, so I'll be able to switch back a little bit more fluidly. I teach math. I don't care. So we have the same log base. So we have log base 2 from both sides. Basically, you're kind of just ignoring it, right? If we want to solve for x, the only way that 3x can equal x squared minus 4, or the only way that equation can be equal is if that's true, if x squared minus 4 equals 3x. So let's set that up. So if x squared minus 4 equals 3x. Now what I like about this problem is because now we have to bring back old ideas. Old ideas that we haven't seen in a little bit, but we keep revisiting. So, and if you couldn't tell, this is a quadratic equation. All right, we haven't gotten into that form yet, but it is a quadratic equation. To get that in the form, we're going to subtract 3x from both sides and set it equal to 0. Okay, so this is throwback a little bit, right? Quadratic equation, x squared minus 3x minus 4. And this brings back everyone's favorite thing in the world to do, which is factoring. Now, the book takes it a little bit for granted. Thank you, Digidio. The book takes it a little bit for granted. So you have x minus 4 times x plus 1 equals 0. Now, sorry, real quick. Carla, real quick, did you get that email? Or can you, like, copy that? Because I don't think I want that comment up, just because I don't want people emailing me that shouldn't be. Yes, that is now. Yeah, thank you. So, guys, actually, real quick, I'll have you guys actually try to factor that. So it's been a little bit of time. See if you can factor x squared minus 3x minus 4. So Aiden says the only way you can set them equal to each other is if the bases and the log. Yes, exactly, Aiden. Very good point. So Aiden asks, the only reason why we can do that is because log base 2 and log base 2, right? And that's correct. That is the only reason we can do that. If there were different bases, that's not going to be true. So factoring. Now, some people, by this point, you guys might be able to do in your heads. Okay, and the book kind of takes that for granted, just assumes you can do in your heads. But, you know, if not, that's fine. We can use our X boxes. So a really big theme in this chapter, or this year really, has been factoring and quadratic equations. So we can use our X box. A times C goes at the top. So negative 4 times 1 gives me negative 4 at the top. Our B term, negative 3, goes at the bottom. And we need to find two different numbers that multiply to negative 4 but add to negative 3. And you would brainstorm. There's not that many options. And you end up getting negative 4 and positive 1. So negative 4 times 1 is negative 4. And then negative 4 plus 1 is negative 3. And because our A term, meaning the term out in front of my quadratic, you'll see here, in front of x squared is 1, we can take a shortcut. And our shortcut is just taking those two values we found. Those are becoming our factors. So x minus 4 and x plus 1. Yeah, thank you, Aiden. Yeah, so guys, my stream's going to be delayed, so I'll probably see some of your answers like later on, but I appreciate participating and giving me some answers. That's good. So this is just a throwback, right, how we do this. To solve, you set those equal to 0, and you get x equals 4 and x equals negative 1. Okay, so now this is where things get a little bit interesting with logarithms, because I have two answers, right? So let's look back at the problem. So in your books, look back at the problem. It says the test example. So they give you to solve, and then they give you 4 different options. All right, so right now you guys should be thinking, oh, well, I have 2 answers, 4, and I have negative 1. But that's a problem, because I have 2 different answers I could do. It could be B or D. So I'm not done. I can't just, at this point, I mean, you have a 50% shot, sure, but you're not just going to guess. We can actually get an answer. And so what we do is we want to check to see if they work. So we actually want to check each x value. So let's look at x equals 4. All right, so we'll have log base 2 of 4 squared minus 4 is equal to log base 2 of 3 times 4. So you end up getting log base 2 of 12 equals log base 2 of 12. Okay, and that's true. Log base 2 of 12 and log base 2 of 12, those are true. I'm going to have to write a little bit bigger. It's kind of messy. Apologize for that. And if I were to put in a calculator, I can actually evaluate those. Okay, now let's take a look at this one. So I'm going to do it in red. Log base 2 of negative 1 squared minus 4 equals log base 2 of 3 times negative 1. I know I don't necessarily need to write that all out like that, but maybe that'll help some people. And you get log base 2. Negative 1 times negative 1 is 1. Minus 4 is negative 3. Equals log base 2 of negative 3. Molly said, where do we get the 2 from? The 2 was, are you saying the base 2? I think if you mean where did we get log base 2 from, it was in the original problem. So the original problem gave us that 2. Okay, so you guys can see in your books, they talk about this. So this exact process, sorry Chris, why don't we use the negative, oh we do use the negative 1. I think my stream's a little bit delayed, but yeah, we do use the negative 1. So we have to do them separately, one where x is negative 1, one where x is 4. So hopefully by now you're seeing that process. So anyways, if you guys look in your book, it says the same process we just did, okay? Now, if you notice that it definitely is true that log base 2 of 12 equals log base 2 of 12, and theoretically log base 2 of negative 3 should be equal to log base 2 of negative 3. The issue is this: the domain of a logarithmic function cannot be 0. So log base 2 of negative 3 is undefined, meaning negative 1 is an extraneous solution. Alright, so if you guys think about it, think about our log graphs. Actually, better yet, here I'll switch my camera, and let's take a look at a log graph. Alright, so we go to Desmos, right, and we have log base, whoa, that's not what I want. We have log base 2. Or better yet, we'll do log base 2 of x. Okay, so this is the situation we basically have here. Let me go full screen. This is the situation of the graph, right? We specified x at 2 different values. One where x was 4, one where x was negative 1. Well, 4 is right here. And we definitely have a point, right? We have a point at 2. Okay, so this is definitely a value on my graph. Well, what about when x is negative 1? Here's negative 1, right? If I keep zooming out, does that graph ever hit negative 1? If you follow that red line, it never does. It just stays at 0 because that's what we call an asymptote. Remember, our asymptote you think of as like a wall. It's a wall that cuts off the line. It's a wall that's impenetrable. You can't pass it. It's saying like you stop here. All right? So this graph is like trying as hard as it can to get over here. It's not going to happen. So that means negative 1 isn't actually an x value on this graph. It has no y value, which is an example of what we call an extraneous solution. And that's what we have right here. Because of that, your answer would be D. So your only answer is 4. Would be the only thing that would make sense. Okay, I know that was a lot. So let me get some feedback in the chat, maybe some thumbs up, some questions, anything you guys got on that. Aiden said he's good. All right, good to hear. Chris, hopefully I answered your question. Like to see you drink. Actually, Jaden, it's water at the moment. I think I got it. Okay, I haven't got it. Good. All good. Okay, cool. So it looks like we have a pretty good understanding of what's going on here. I'm double checking real quick. I want to make sure I can hit on every problem you might have for homework. 8 through 19. Yeah, okay. So you guys should, that's the type of question we're going to be going over for homework. So that's good then. Let's do one more. Oh wait, okay, hold on. Oh no, real. I'm good, really. Yeah, Jaden. Yeah, it is water. I have coffee over here, but I have a lot of energy, so I'm actually okay. Okay, so guys, in your book, I want you to do that standardized test part. I want you to do the guided practice. So guided practice 2. I want you guys to try solving that on your own. Okay, in about like, I don't know, 5 minutes, I'll check in and we can get started and we can go over your work. Aiden, well done. Yes, that is correct. Damon, I'll be going over it. No worries. Just get where you can. Jaden, good job. Chris says, do they have to be true? If I think yes. They no extraneous solutions. So meaning if it's not in the domain, if your answer is not in the domain, then it can't be an answer. H, yeah, good. Okay. About a minute or probably a minute more. Let people finish up that want to challenge themselves a little bit. This will be the last problem we do, and I'm gonna as a class we're gonna take a look at this Google Classroom situation and see if I can figure out what's going on. Chris said, "Okay, good, Chris, you got it." Okay, so I'm gonna start going over this. Make sure if you didn't answer in the chat or you were confused or not quite there, maybe stuck somewhere, make sure you pay attention to this. So you guys can see the problem. I'll write it down anyways. Log base 3 of x squared minus 15 is equal to log base 3 of 2x. So we know the bases are the same. So log base 3 for both of them, which means that the only way that statement is true is if the inside function is equal to each other. Meaning, is x squared minus 15 equal to 2x? It's got to be true. Okay, and then this is just a quadratic equation that we can solve. Again, people have different ways to do that. If you do in your head, do in your head. I'm going to do an X box just because it's good practice. So A times C gives you negative 15. B is negative 2. So recap again. Set them equal to each other. It's a quadratic equation because we have an x squared. So we're going to have to factor to solve for x. We got to factor. So B term is negative 2. What two values multiply to negative 15 add to negative 2? You should have found negative 5, positive 3. Again, my A term up here the term in front of x squared, or the coefficient, I should say, in front of x squared is 1, meaning I can take the shortcut of x minus 5 times x plus 3 equals 0. So that's my factor form. That's kind of the hard part, really. And based off of this, I know that x can either be 5 or x can be negative 3. So I'm down to 2 answers. I'm down to either F or I'm down to H. So I have that option. Like Chris was saying, you have to still check to see if they're true, just like we did in the last problem. So basically I want to see, all right, let me specify. When x equals 5, I have log base 3 of 5 squared minus 15 equals log base 3 of 2 times 5. So I get log base 3 of 10 equals log base 3 of 10. And really, you guys can stop there, because you know that there can only be one answer, right? It has to be one of the options. And we know that this one gives us a positive domain value, which means that it isn't an extraneous. It's a good solution. It's a solution that exists. So if there's only one possible option, you can just stop here. You know the answer is H, or 5. Okay, so that would, at the end of the day, that's your answer. You can stop there. But just for the sake of the argument, let's say you decided to test negative 3 first. Let's just assume you did that. So we would have log base 3 of negative 3 squared minus 15 equals log base 3 of 2 times negative 3. And then you end up getting log base 3 of negative 6 equals log base 3 of negative 6. Now, negative 6 is an extraneous solution, so we can't have negative log values. Now, I shouldn't say that. There's possibilities where we can, but with a parent function like we have here, there's no transformation. So there's nothing that's shifting this graph where we might have negative x values. All right, and if you get a calculator, you can just check. You can plug that in and see that's not going to give you an answer. Okay, so yeah, your answer is H. X equals 3 is not going to work. All right, Molly said I just plugged in every optional number into the equation for x until both sides of the equation were the same. So Molly, good strategy. You can eliminate answers doing that. The only thing is that you're going to get 2 possible answers, right? So that would eliminate the factoring process, which I like that actually a lot. So Molly basically can eliminate factoring by just plugging in these values and seeing which ones make it true. As long as you understand, you still have to find which is the extraneous solution and which is the actual solution. So great, Molly. Yeah, that's perfectly fine if that's the way you want to go about doing it for the standardized test problem. Good job. Any other comments or concerns? This will be the last problem for today. I know I'm on a delay, so I'll give it a second. I'm trying really hard to not talk as fast, but I'm failing pretty miserably. I realize I talk fast in general, so it's really hard to tone it down, but I'm working on it. Alright, so I'm not seeing anything in the chat. I don't know if maybe you guys haven't gotten to the part where I've asked yet. Okay, Jane just said something. That is okay. Good, good, good. What I want you guys to do now is go to Google Classroom and let me get some feedback on what's going on. So I'm going to go there now. Hi, Destiny. I'm not really sure what this subject is called because I got here a little late. So Destiny, this is 7.4. This is solving logarithmic equations. So that's what you can title it, solving logarithmic equations. Destiny, just so you know, and for anyone, I have these posted to YouTube. So everything I've said so far will be back on YouTube, and it'll be like you were in the stream. You just can't comment, obviously, and because it's not live anymore. But once I post it to YouTube, you guys can watch the video again, and I'll put timestamps when your class starts. So don't panic if you get in late ever, if you ever miss a stream or anything like that. I'll always be posting videos, so you can still be engaged. Okay, so yeah, guys, make sure you're in Google Classroom. And when you're in there, in the chat, just kind of describe maybe, oh, actually, never mind. I figured out why. I'm very stupid. Give me a second, people. So stay there, though, and refresh your page in a second. Okay. 1 second, Heaven. I just posted it now. I forgot I saved it as a draft. So it should be up. If you guys refresh your page, it should be up now. So give me a little bit of feedback. Make sure I'm good with that. Got it up. Okay, perfect. All right, so guys, do you see a spot where you can submit stuff? Is there a way you can make attachments? Kind of fill me in on what you're gonna have to do to actually do it. Yep, it's up. Okay, very good, very good. Okay, so my question, I guess, for you guys, everyone can see it. My question is, is there a way you can take a picture? Can you send a picture through? How does that work? Click add or create. All we should need to do is get the phone laptop and add. Okay, perfect. Because the way I see it, like on my screen, it doesn't let me. Okay, actually, let me just change. So like on my screen, this is like the page it takes me to. So if you guys can see, this is like what I see. And I know in like the comments, you add a class comment, you can't post anything. So I'm hoping yours is different. Yeah, it looks like there is. There's place. Okay, you can take a photo, put it in your desktop, and drag it. Okay, perfect. So yeah, there's a bunch of options you can do. So maybe just mine doesn't show how you can upload it. Because for whatever reason, like I don't know. That's fine though. You can take a picture of it, then click and create. Okay, we could put our answers on a page and turn it. Okay, that works too, Isaac. If you want to put it on a pages. Yeah, okay, there's plenty of options you guys have. So if anyone needs it, all these comments are great comments if anyone's confused on how to do that. Also, so like what Heaven said, you can do it on your phone, you can add attachments. Yeah, so guys, if you get the app, just get a Google Classroom app, and then take the picture and just upload it right on the app. I mean, it's pretty easy in my opinion. That's probably the easiest option. If you have a smartphone and like you have internet and everything, that's what I would do. So you guys can see this is worth 4 points. Due tomorrow at 3:30. So I will be checking. This is like our practice round. I'll be giving you points though. It'll still be graded. So this will be my way to kind of see how everyone's doing, how everyone's work. Like I said, it's everything I did today in the lecture is going to be on the homework. So there shouldn't be any no curveballs thrown your way. Okay, very good. Well, that will end today's stream, guys. So I will stick around for like a second longer. If you guys have anything else you want to mention or comment or feedback, anything you want, but yeah, I'll be here for the next 5 minutes. But if you guys are good to go, then you're free to leave. Thank you for attending the stream today. If you want to watch the recap, you can watch the YouTube video. You can pause the work. You can see my work, step by step. Maybe get a re-explanation of things. And hopefully this is helping you out. So, Justin, ignore the email. Okay. Yeah. Thank you, Justin. Jared, you can also on your phone take the picture and send the phone. Yeah, that's another option too, Jared, if you need to do it on your computer. Michael, you don't want that, Michael. Trust me. Guys, as a reminder, if you're still here, my office hour is going to be from 1 to 2. So I'm going to take an hour to eat some lunch, and then I'll be back on 1 to 2. I will be live. I'll just be sitting here kind of awkwardly sitting here waiting for you guys. And then from 2 to 3, I'll be answering any emails you have. So if you guys have any questions, just send it over email if you can't make it from 1 to 2. Jaden, you did a really good job. Hey, thank you, Jaden. Appreciate it. You have a good day, too. I like the positive feedback. It makes me feel good about myself. You don't want us. Okay, Michael. Okay. Maybe one day. That's what I need to do. I need to post a YouTube video of me playing 2K so you can see what you'd be in for. No, I talk a lot, but I haven't really actually played 2K in that long, so I don't even know if I'd be good at it anymore. I just know I used to when I was in high school. I used to play it a lot. Oh, Aiden, thank you. Guys, make sure you like and subscribe. Comment on the video. Tell me what you think. And hit that notification bell so I can make sure that you can get all notifications of my videos. Let me know how that was, Aiden. I maybe a little bit more enthusiasm. I'll work on it. It'll get better. All right. Sarah said, I'm a little confused on the first thing we did, the very first problem we did today. Do you have a split up or can we just solve it as is? Very first problem, Sarah. So I'm assuming what you meant was, do we have to split it up or can we solve it as? Okay, I see what you're saying. Yeah, we have to split it up to start, Sarah. So your first step has to be rewriting it as an exponential. So like if I'm going to put this screen on so you can see. If you look back at this beginning problem, notice that I started by rewriting, so 36 was a base raised to the 3 halves. Because we don't have a calculator where we could just plug in this and it gives us like an answer, right? So we have to rewrite it first so x is by itself. But from here, if you want to, you can put that in your calculator. So you can just put in 36 to the 3 halves and solve it. And you'll get 216. Hopefully that was what you were talking about. Lily said, where should we submit the photo at in Google Classroom? Lily, if you click on the assignment, I believe there's a spot where you can upload a link or a file of some sort. And that's where you submit it. So the assignment's posted to Google Classroom. Sierra said, we love the live streams and being able to talk about our work while you're right here. A lot of other teachers said to email. Yeah, I'm glad, Sierra. That's the goal. I think it's beneficial to have someone to bounce ideas off of. You have each other to help out. And then also, obviously, me. I can go through stuff. I don't know. I think it's very useful. So I'm glad it's helping. Thank you for the feedback. Aiden said, perfect. Smash that notification bell. Just smash the just smash all the bells. Damon, what 2K did you play back then? 2K4? Yeah, Damon. Actually, it was 2K96 is what I played. Hold on. Before I finish this problem, smash that like button in 3, 2, 1. Oh, man. I got to work on that, Aiden. I need you to guide me in the ways of a streamer. All right, good, Sarah. Glad that helped. And plus, we should do a 2v2 one day with Miss Ayers. Hey, when you guys graduate, meet me on the courts. All right. I think we should be good, guys. So I'm hungry. I'm gonna go eat some lunch. I appreciate everyone attending. Hope this was useful to you. I hope everyone enjoyed. I will be back on tomorrow, same time. And like I said, from 1 to 2 today, I will also be here for live stream. So if you guys want to work on your homework till then, whatever you want to do, I'll be available for you. So peace out. See you guys.